Hello guys, my teacher N sucks, that's yours, otherwise you won't be here. So this is chapter 2, energy transfer and general energy analysis in my thermodynamics textbook. In this video we're going to learn how to apply the first law of thermodynamics, or we call it as energy balance. Don't worry, I won't go through the theory, how to derive formula. I will teach you how to apply and ask you to understand how to use the formula. This is what you want to score in exam. So there are two formulas in this case. E in minus E out equal to delta E of system, and another one. And net heat transfer minus the net work transfer equal to delta E of system. And the tips here are, in this one you can just use the direct substitution method to do it, which is better and easier. And for this one you need to consider the positive and negative sign of the work and the heat to avoid the positive negative sealing mistakes. So we go to example directly. In example 1, a tank contains fluid that is cool while being stirred by a paddle wheel. Initially, the internal energy of the fluid is 800 kilojoules. During the cooling process, the fluid loses 500 kilojoules of heat, and the paddle wheel does 100 kilojoules of work on the fluid. Determine the final internal energy of the fluid. For the question, you should be immediately step out your state of your fluid, your initial state and your final state, and the heat out of the system and the work into the system. Please, I apologize for the typo error here. So this is the picture. If you cannot imagine it out, you can pause the video to go through it. So the first method is to apply such formula: E in minus E out equal to delta E of system. So the next step, you're going to write this. The energy in is very simple. The heat transfer into the system plus the work into the system, while the energy out is just nothing but the heat transfer out of the system plus the work out of the system. So if you can know this, you can know this. And delta E of the system is always the change in the internal energy, change in the kinetic energy, and change in the potential energy. This is only applicable for closed system. But in this case, there is no heat transfer, so we can directly cancel. No work out of system, no kinetic energy change of the system, and no potential energy change of system, which you can simplify the equation into such, which you are gonna need 4 variables here. Oh no, you're gonna need 3 variables to solve this. While 3 of this is given, so you can just directly substitute to get the U2, which is equal to 400 kilojoules. So next, this is the second method you can solve that equation. You're going to start with the Q net minus W net equal to delta E of the system. So the tips here are, be careful of your in and out of system. This is fixed. You should memorize this. Don't ask me how to derive this. Sorry, I won't go through because I know this won't be tested and then you just know how to apply. Okay, Q net, careful. Heat in minus heat out, while the W net, the net work is work out, or we call it as work done by the system, minus work into the system. Again, I repeat, W net is nothing but work out or work done minus work in, and the rest of the right hand side should be similar to the previous. And also this only applies to closed system. So you can cancel the variables that are not applicable in this question, which left you 4 variables and you need 3 to solve the rest. which is given the Q out, W in, and U1. So solving the mathematics, you can get U2 similar to the previous answer. Okay, I'm going to tell you how to solve the second example now. So I started with okay, you go to the question first. Okay, what you need is just Q in, and then delta E is -5 because it's decreased. It will be +5 if experience an increase only. So you're gonna find out the work done. So you start with this formula: E in minus E out equal delta E of system. I hope you can memorize this now. And cancel out the things that are not applicable in these questions and left you 3 variables. And the delta U is already given, which is -5 because it says decrease. Now we're going to do some mathematics and get the W out, which is 10 kilojoules. Isn't this hard? Not at all. So the second way is using this formula. Again, you should be memorize this. Q net is Q in minus Q out. W net is W out minus W in. So you cancel the one that is not applicable, and which simplifies into this. And substitute it, you will also get similar answer. And that's all for today's tutorial. If you like this video, please click the like button below and subscribe. Thank you very much for watching this. Thank you.